In this example, we want to find the roots of the polynomial p of x equals x cubed minus x squared minus 2x plus 2. In other words, we want to find the solutions to the equation x cubed minus x squared minus 2x plus 2 equals 0. We saw that to find rational roots, we can use the rational root theorem, which says that if p over q is a root of our polynomial, then p divides the constant term a0 and q divides our lead coefficient an. For this particular p of x, we have that our constant term a0 is 2 and our lead coefficient a3 is 1. So this means that p divides 2 and q divides 1. So the possible values of p are all the numbers which divide 2, plus or minus 1 and plus or minus 2. While the possible values of q are all the numbers that divide 1, which is just plus or minus 1. Now all the possible values of the roots p over q come from p in our first list over q from our second list. And we need to look at all possible combinations. Well, the only thing we can pick for q is plus or minus 1, but for p we can pick plus or minus 1, which over q is just plus or minus 1 over plus or minus 1, or we could pick p as plus or minus 2, giving plus or minus 2 over 1. Now we need to evaluate p of x at our possible roots to see which ones are actually roots. Evaluating p of x at our possible roots, we need to check at 1, -1, 2, and -2. Doing this, we find that p of 1 is 0, but p of -1 is 2, which is not 0. P of 2 is also 2, which still is not 0, and p of -2 is -6, also not 0. So the only solution we found was x equals 1. But this is a degree 3 polynomial. There should be 3 roots. Where are the other solutions? Well, since x equals 1 is a root, the factoring theorem tells us that p of x can be written as x minus 1 times some other polynomial q of x. And to find q of x, we need to compute p of x divided by x minus 1. If you'd like to see the steps of this computed out, you can click the purple link now. Doing this, we find that q of x has to be x squared minus 2. So our equation becomes 0 equals x minus 1 times x squared minus 2. And by the zero product property, either x minus 1 is 0 or x squared minus 2 is 0. In the first equation, we get that x equals 1 is a root, but that's the root we already knew. For x squared minus 2 equals 0, we can solve this by adding 2 to both sides and taking the square root, which gives us that x equals plus or minus the square root of 2. So we can conclude that the roots of p of x equals 3x cubed plus 2x squared minus 7x plus 2 are the values 1, square root of 2, and negative square root of 2. It's worth pointing out here that the rational root theorem did not find the roots plus or minus square root of 2. This is because they're rational numbers, and the rational root theorem only finds rational roots.